Hi everyone, we are back and we are going to be going through our practice exam problem 1. So, for A, label all the directions, and for B through C, label all the planes. So, I'm going to do planes first because I like doing that. So, we see that we have our origin, the plane is crossing it, so I'm going to redefine my origin here. This is my new x, this is my new y, this is my new z. So my x-intercept is going to be a half, my y-intercept is going to be -1, z-intercept does not exist, so my HKL indices will be the inverse. So it's going to be 2, 1 hat, 0, and that's it. I'll do the same thing for here. See it pop up. My x-intercept equals 1, my y-intercept equals -1, and my z-intercept equals 2. So I flip those, and, or actually, it's not 2. See, a half. And it'll be 1, -1, 2. There we go. Those are all of the planes. So remember, find the intercept, and then reciprocal for x, y, and z. Directions. Let's go ahead and let's do this one first. I like that. So my finish is 0, 0, 0. My start is 0, 1, 0. So my direction is 0, 1 hat, 0. This one right here, my finish location is 0, 1, 1 half minus my start, which is 1, 0, 0. So that's going to leave me with 1 hat, 1, 1 half. And then let me scroll up here. So I'm going to multiply everything out by 2. So 2 bar, 2, 1. And then finally, this one right here, my finish vector coordinates are going to be 0, 1 half, 1 minus my start, which is 1, 1, 1. And that's going to leave me with 1 hat, 1 half hat, and then 0. So that's going to leave me with eventually 2 hat. Actually, excuse me, let me make that a little bit clearer. So I'm going to take this as my, what I've got, put it over here. So that's going to be 2 hat, 1 hat, 0. Directions, planes. What is the conventional unit cell in A and C? So A, I am BCC. In C, I am simple cubic. What are the number of atoms? Number of nearest neighbors in APF. So the number of atoms here is 2, 1. Number of nearest neighbors, this is going to be 8, this is going to be 6. The APF, these are both less than 0.74, but you want to give the actual number. Are any structures close packed? Nope, nope, but B is actually. Are there any primitive cells? Yes, simple cubic is a primitive cell. Determine calculate the planar density of the plane in B. So that's going to be a little bit, so we can go ahead and look at what this is going to look like here. So it's a rectangle. We see that we are only effectively touching an atom here, an atom here, and an atom right here. This distance is A. And if we look at this triangle here, we have a triangle that looks like, excuse me, we have an A length here and an A over 2 here. So if I want to look at this, bring up Mathematica. And I promise I won't do this to you on an actual exam, but let's make the practice exam a little bit difficult so that we can get moving here. Almost there. So we got this. So I'm going to go solve a squared plus a over 2 squared set equal to x squared. So x, or basically I'm going to have root 5a over 2. So, excuse me, that's going to be right here. So if I want to look at the planar density, this is going to be a quarter, quarter, half. So I can plug in that for my number of atoms. So my number of atoms is going to be quarter, quarter, half, so basically 1. So I'm going to have pi times r squared, times r squared, divided by square root of, divided by a squared, where my a, and this is the a in terms of FCC, a of FCC is equal to 2 times r times square root of 2. So A of FCC is not squared, although times A of FCC times square root of 5 divided by 2. And 0.3512. And that is not close packed. In D, draw conventional unit cell. Draw the FCC. So this is my FCC. I'm going to erase it immediately afterwards. At each of the 6 faces, here as well. So that's my FCC. I'm going to draw my plane first. So the plane, I'm going to have an intercept, so I have to go down. So actually I'm going to go like this. My x-intercept is equal to 1/2. My y-intercept is infinity. And my z-intercept is equal to minus 1/2. So I'm going to go here, 1/2 minus 1/2. I'm going to draw that. I can do the same thing here. Draw this, and then I could connect the cells like so. So that would be that plane. I could also ask for this direction. So to do that, let me just erase here. So I need to do, this is what I'm trying to get. I defined that as like my new origin when I was drawing those solutions. So finish minus my start, which is going to be, so I want to make this to be, I'm going to call this 1/2 1. I'm going to call this, actually, excuse me, I'm going to change this to 0 1. We're going to call this 1/2 0, and I'm going to call this 0 1 as well. And that will give me those values. And so I can do my start, which is going to be 1 0 1. So 1 0 1, and my finish is going to be 0 1/2 there. So it's just going to be like this. There we go. Excellent. Are these directions close packed or planes? No, they're neither. And we should know for FCC, the close packed directions are going to be what? My close packed directions are 1 1 0. My close packed planes are 1 1 1. There are no close packed planes for those other values. All right, let's look at the PDF. So the first peak, the integral of the first peak is 12. So automatically I know this material is FCC. So I know that this distance is going to be 2r. This 3.54 is equal to 2r times square root of 2. So I can go ahead and solve for, I'm going to solve, 3.54. Solve 3.54, set equal to 2 times r times square root of 2. This is indeed a metal. So my r is 1.25, so my 2r, so this times 2 is equal to 2.5. So I'm going to call this 2.5. We know it's FCC, we know it's a metal, so we can actually find out what the material is. So I need to go to my handy dandy periodic table. I'm going to go Control F, 1.25. I need to look for metallic radii. Let's go, come on. Where are you? 1.25. Well, let's go look at it the hard way. I don't know why it's not. Why aren't you behaving today? Here, let's do 1.2. All right, we're not looking there. We're not looking here. We want to look at the other. All right. Nope. Manganese, no. 1.26, but we're looking for FCC. Not BCC. So let's go ahead and look on the other page for FCC. So, nickel, right there. 1.25. So that's my metallic radii. We got them. That is indeed nickel. So let's go ahead and see what else we had in store here. This was a new section. What is the next nearest neighbor distance? We found that. What element? We've got it. And that's it. All right. I'll see you next time for problem 2. See you then. Bye.